In this video, we're going to learn about factoring quadratics. Now, by quadratics, we're talking about polynomials with a squared term as the highest power. And when a is greater than 1, what we mean by that is that there's a coefficient greater than 1 in front of the squared term. Now, before factoring quadratics where a is greater than 1, we learned how to factor quadratics where a equals 1. For instance, if we have x squared plus 6x plus 8. We try to break it down into its factors. Now to get the x squared, we know that has to be x times x. And then to get the 8, it's either going to be 1 times 8 or 4 times 2. So we can make a little diamond problem to help us organize our thinking here. We need two numbers that multiply to make 8 that add up to 6. Well, let's see, 4 times 2 equals 8, and 4 plus 2 equals 6. So the factors are x plus 4 and x plus 2. Now that was how we can factor quadratic expressions when a equals 1. But in these examples, a is greater than 1. And this method doesn't quite work. Okay, we can think of it the same way. We're still going to try to break it down into two binomials that multiply to make 5a squared plus 14a plus 8. Okay, we know it's going to be 5a times a to get that 5a squared. And then these two numbers here need to multiply to make 8. But when we multiply it all out, that middle term needs to be 14a. And here's a good way to figure out that middle term. Now, when we make the diamond problem, when a is greater than 1, we start by multiplying that coefficient of a squared by the constant. So in this case, 5 times 8. And that number goes on top of the diamond problem. And then we'll put the 14 on the bottom. So here we need two numbers that multiply to make 40 that have a sum of 14. Well, let's see, we have 1 times 40. That's not going to work. They have a product of 40, but they don't add up to 14. 2 times 20. That doesn't work because they add up to 22. 4 times 10 have a sum of 14. Okay, so we figured out that 4 times 10 equals 40, and 4 plus 10 equals 14. Now, unfortunately, these are not our factors. If we use those, it wouldn't quite work out. But what they do help us with is they help us fill out a rectangle. Now, in this rectangle, we'll have the 5a squared in the top left corner and the constant term in the bottom right. And what these wing numbers tell us, they tell us what go in the missing boxes here. So we have 4a and 10a. Okay, let's figure out some binomials that multiply to make these terms. So we know to make 5a squared, it's 5a times a. So let's see, I don't want to put the 5a on top because that lines up with the 4a, and it's hard to turn a 4a or 5a into a 4a. So let's put the 5a on the left side because that lines up with the 10a. And we can turn 5a into a 10a. So we have 5a times a equals 5a squared. Now, 5a times 2 equals 10a. A times 4 equals 4a. And just double check, 4 times 2 equals 8. Now we have our factors. It's 5a plus 4 times a plus 2. Now if we multiply these two binomials, we end up getting this original polynomial that we started with. When you're factoring, remember to write out the factors. You don't just want to have your box and the diamond. We still need to write out the factors. Okay, at number 2, we notice we have a coefficient greater than 1. So when we start with our diamond, we're going to multiply 5 times negative 6. And the sum will be negative 7. So we're trying to think of two numbers that multiply to make negative 30 that have a sum of negative 7. Let's see, let's start in the middle this time. We have 5 times 6 equals 30. Now notice the sum is negative, so in all of our products, we'll have the larger number be negative, so they have a negative sum. These have a sum of -1, so that doesn't work there. 3 times 10 equals 30. Let's make the larger number negative. 3 times -10 equals -30, and these two numbers do have a sum of -7. All right, so we figured out our wing numbers. Now we'll go to our box. We start filling in the box by looking at the original expression. That 5b squared will go in the top left corner, and the -6 will go in the bottom right corner. And these wing numbers tell us what go in the empty boxes. So we have 3b and -10b. All right, to get 5b squared, we need to multiply 5b times b. Once again, we think, okay, so we want the 5b to line up with the 10b, not with the 3b. So we have 5b times b is 5b squared. 5b times -2 equals -10b. And b times 3 equals 3b. And we multiply the constants and get -6, so that checks out. Okay, and now we have our factors, 5b plus 3 and b minus 2. And once again, just to remind you that factoring is just like multiplying, but in the opposite direction. If we multiplied our factors out, we would get the original expression. Okay, let's try one more. So we have a quadratic expression here. The coefficient is greater than 1. So when we set up our diamond problem, we're not going to put 20 on the top. We're going to do 2 times 20. And the -5 will go on the bottom. So we're thinking of two numbers that multiply to make 40 that have a sum of -5. So here we have a negative sum and a positive product. The only way to get that is to have a negative times a negative equal a positive. So in this case, in our products, both numbers will be negative. Well, one way to have a sum of positive 40 is -1 times -40. Those don't have a sum of -5 though. We have -2 times -20. Those don't have a sum of -5 either. -4 times -10. Still doesn't have a sum of -5. -5 times -8 equals 40, but they don't have a sum of -5. And so nothing seems to be working. Now in this case, when we can't get our diamond problem to work out, it just means that that expression is not factorable. In this video, we learned how to factor quadratic expressions where a is greater than 1. Hopefully the examples have been helpful. This is Mr. Ela, signing off.